The other speakers today, so thank you for those of you that stuck around after that great keynote. So of course I'm Keith Hoodlet. I'm going to be talking about the concept of security is a feature. Before we get started, I'd like to give a little bit about sort of the perspective that I bring to the table and sort of the things that I've done that give me this perspective. So my current role is a code security architect, or sometimes a code scanning architect at GitHub. Really, that means I get to play with CodeQL all day and sort of find interesting bugs for companies that aren't sort of default within the product space. Sort of a great company to be doing it for, especially in open source. But previously, I worked as a director of application experience at Thermo Fisher Scientific. Most people don't know who they are. In fact, I didn't know who they are until I got recruited there. More than half of the world's COVID-19 testing touches at least one of their products. The human genome was initially sequenced in the 1990s on their device, and the original SARS-CoV-2 virus in Wuhan was mapped on their device at the laboratories in Wuhan. They also make freezers that sort of are used for transporting the mRNA vaccines about. But beyond that, they work in the laboratory science space in forensics. So Interpol, the Department of Justice, and the FBI in the United States and others use their products and devices. Laboratories, especially at universities, use their products for chemical weapons testing. You can imagine who might not want that data to get out. And of course, Olympic Drug Testing Committee laboratories for checking if athletes are cheating also use their products. So you can imagine the sort of fun things that we got to see and work with at Thermo Fisher. I also previously hosted the Application Security Weekly podcast with Paul Asadorian. We start with 0 whenever we count as a development team, so we started with 0 there. I've done some bug bounty hunting, especially against Ford Motor Company, Netgear, and others. I love to write code in Visual Studio Code even before I worked for GitHub, and now especially. Python, Bash, and JavaScript are sort of the things you'll see on my open source projects, and I've worked on a few as well. Other than these last 2 years, I love to travel, learn new languages. I have yet to pick up Irish, but someday, I promise. And otherwise, I'm reading and writing, sometimes traveling and programming. So let's start by thinking about what do your development teams, your project management teams, your product teams think about as a feature? They're first going to think about what the customer is asking for. I want an edit button on Twitter. I still haven't got one yet. But again, customers will ask you for things, right? Your company will spend time and money on the things that your customers are asking you for, and often allocate people, teams, resources to that. They will take those features and they'll make sure that they're tested, that they don't break every time you have a new release, and that over time they sort of get better, right? Again, I still want that edit button at Twitter. So again, traditional features. So why isn't security considered a feature by these development teams? Why aren't they allocating time? Just by a show of hands, how many of you have some sort of banking or finance or investment application on your phone? Nearly all of you. So that's the first question I ask the development team. The second question I ask them after we've done some sort of scan of some kind or some sort of manual security test is, would you use it if it had the vulnerabilities that your application has? And the look on their face is sort of one of three things. Either you've just called their baby ugly, they can't believe you said that, or total disbelief, and absolutely not. And it's sort of this expectation that the things you're using on your phone, on your device, or on your computer are in fact secure. They won't ask you for it. And I say, in any of the countries I've visited so far, and if you know of one that's different, please tell me after this talk. When you go up to a water faucet that has two handles, and you twist the one that's on the left, it's hot. You didn't have to ask for it to be that way. You didn't have to ask for that to be installed that way. It is just that way. And security is sort of that expectation that when you open that application, when you give it credentials or your personal information, that it is in fact secure. Hint, it's usually not. But again, expectations. Of course, same thing as well. If you're not building security into your application, it is both costly to fix, and in some cases, you have to sort of do a total rebuild. Challenges that we saw at Thermo Fisher included software that had hard-coded credentials in laboratories that were doing chemical weapons analysis. And the sort of sudden need to fix that was a breaking change for some of these laboratories. And that wasn't going to work very well. So, of course, many hours were spent, a lot of money was spent to now have to go and remediate that because of regulatory requirement. And then finally, your security will often be tested. Whether you know that or not, or whether someone is willing to tell you, is an entirely different thing. And I say in some ways it's like cellular. You sort of expect it to work everywhere, and then suddenly you get into a brick building, and not so much. But again, all these things are sort of pointing to that security should be thought of as a feature by your development teams and your product teams, but it's just generally not. So again, those two questions: do you have a finance or investment or banking application on your phone, and would you use it if it had the vulnerabilities that your application now has? And we know that they have. So what happens when you don't treat security as a feature? We have multiple examples of this. One sort of great example is Capital One. Back in 2019, they had a breach of over 110 million users' credentials and other sort of information. They were only fined $80 million US, which I thought was rather low. But one of the sort of bigger problems that they had as a result of this is right after this breach occurred, many of their security organization left because they knew about the vulnerabilities that were used to exploit these holes in their code. They shared them with development teams. They brought them to the executive level. The CISO was screaming up and down, and nobody did anything. So the human cost, as we all know, it's hard to find, retain, train security talent, and gone very quickly, sort of overnight, because they just didn't want to put up with it anymore. Of course, it also leads to bad publicity. Uber is another one of those companies where they had a bounty-ass data breach, where the CISO or CSO, Chief Security Officer, or sometimes referred to as Chief Scapegoat, said, we're going to pay $100,000 to this bounty hunter in Florida to not release the information from this breach. And ultimately, that individual was fired. They were brought up on wire fraud charges, and it cost, in just the fines alone, $148 million US to the company. That's, by the way, if you take half of that for a Fortune 100 company, that's a pretty good budget for a security year, just 1 year, right? You probably don't even need, say, 10% of that to have a pretty good security budget in most organizations today. And then there's sort of the interesting example of Zoom. People still continue to use it today, and it's sort of wildly popular because it's free most of the time for those that use it. But right at the beginning of the pandemic, January of 2020, it turned out that they did not, in fact, have end-to-end encryption like they were claiming, according to the FCC in the United States. And a series of other vulnerabilities in their installed software was sort of piled on top of that. Now, can you imagine? The world is just about to go fully remote. Companies are about to make multi-million-dollar decisions for over multiple years for the solutions that they're going to use to now allow for people to be fully remote. And you didn't treat security as a feature. And now the world knows it. People are going to change their mind about whether or not they're going to use you, or they're going to get a pretty steep discount in the offing for it. So again, things happen when you don't treat security as a feature. It will eventually catch up to you. And in some cases it has. And it really doesn't have to be this way. There's sort of several layers at which you can approach this. And my original background is in psychology, so I like to go back to the 1990s in New York City in the United States, where there was sort of this concept of broken windows theory, which is you'd have rampant crime throughout the city, but you saw that if a neighborhood had broken windows that were boarded up with plywood, you'd start to see graffiti. And as you start to see graffiti, you start to see drug sales. And as you start to see drug sales, you start to see violence. And it all started with the broken window. And in a lot of ways, as a software engineering organization, if you fix the broken windows, you sort of stop all of the after effects that take place. And they proved this out with the subway cars that had graffiti all over them in New York City. They would take them out of sort of commission, repaint them, send them back out. Crime went down. Sort of quick fix, right? Same thing can happen in your applications. If you sort of catch things early, sort of go about fixing those things early, you can prevent those longer term security problems that ultimately crop up and then leads to some sort of event in your organization. I also like to say security is unit testing. My wife taught me how to cook, and the first and most important thing was check your ingredients, right? No matter what recipe you're making, if your ingredients are bad, it will taste bad and possibly make you sick. So when you're going about sort of starting as security, think of it as your unit testing, right? Everybody always thinks about unit testing in software development to make sure things are working. Well, guess what? Security can, in fact, be a unit test as well. Look at static analysis, and I have recommendations of some free tools available to folks as well on that front here in a couple of slides. But just look at the recipe, look at your code and determine what's bad about it. Also, look at your supply chain. Or dependencies, right? What sort of ingredients are you pulling in from open source? Like the, was a Node IPC open source project that recently ruined a lot of people's computers. I have sidebar commentary for that I will share later over drinks. But needless to say, check your ingredients, check your recipe, start there because it's the earliest place that you can start to invest in security other than, of course, training. And then begin to treat it like integration testing as well. A lot of the times, especially in static analysis, if you're working across microservices, you're going to have an input that makes it into another part of your application that isn't sort of enclosed in that microservice that you initially checked. And it's not treated as bad in the next microservice when it comes in. So, as I say, throw spaghetti at the wall to see if it sticks. That's a great way to know that your spaghetti is done. Or in this case, use fuzzing, use dynamic analysis, throw things at your application to check your mitigations, your controls, your actual sort of sanity checks inside of your code to make sure that, in fact, yeah, this thing is secure. For example, when I went to a hospital recently and had to sign in and put my birth date in there, I hit the backspace key too many times and then accidentally hit enter. Had a buffer underflow. Suddenly I was in a Windows XP prompt in this hospital network, and I was just like, nobody tested that. Nobody even thought that, okay, maybe if we give it less than what it's asking for, it would be a problem. Again, throw spaghetti at the wall, fuzzing, see what happens. And there are a lot of benefits to doing this. First of all, attack complexity increases. Now, a lot of organizations continue to get breached because of phishing attempts, and they're going after sort of traditional security vulnerabilities. But if you look at payouts in the zero-day market for a lot of software, especially in the mobile space, both Android and iOS, it's getting more expensive because those companies are investing in security, and so therefore exploiting those applications or exploiting software on a phone is getting harder. It's the likes of the NSO group that are able to continue to do that. But again, very small threat landscape by comparison, which means that the people that you're worried about attacking you are a very specific set of actors. And they're usually very persistent about trying to get you one way or another. It also differentiates in products. The key example I always go back to here is Apple. While Apple has its ups and downs, and Patrick Wardle of Objective-C could point to a number of the different security vulnerabilities associated with it, it is considered one of the more secure mobile platforms out there by default, which is a good thing, especially related to privacy. We also see this in frameworks as well. When you look at React.js versus the original Angular.js. Angular.js had this sort of interesting concept of the sandbox. Well, the folks over at Portswigger did a really good job of finding sandbox escapes. I had the great pleasure of building a sandbox escape to full reverse shell using an AngularJS framework with template injection during a training that I've given. And again, it was because they treated the sandbox as this sort of security thing, released it out to, I think, version 1.8 or 1.9, and eventually they said, we're going to scrap the entire sandbox. Well, that brought it all the way back to just version 1.1, and you still had the same vulnerability, which became a breaking change when they released Angular 2. Whereas with React, they sort of called those things right on the face of it. You want to dangerously set inner HTML? Okay, you can. But it's dangerous, and it tells you right there that it's dangerous. And as a security professional, it's kind of very easy to grep your code and say, yeah, this says dangerous on it. Are you sure you want to be doing that, and why are you doing that? And here's how you exploit that. But it really sort of differentiated at the framework level and the applications that then were made off of those frameworks, the sort of security that could be implemented in them by default. And ultimately, that saves you time and money because usually when an event occurs, you're suddenly dropping everything. All those features that you were working on that customers were asking you for now get delayed by weeks or months. And you're suddenly now needing to reach out to a Mandiant or somebody else and spending hundreds of thousands or millions on remediation efforts, let alone actually now figuring out how this could be fixed in the long term. So it will eventually cost you something, but small investments made up front tend to have a bigger payoff over time. So where to get started, right? As if you're in an organization, I always say the things that you actually need to care about are not necessarily security related, but will have profound and compounding sort of impacts on the way that you implement security. First, your speed of deployment. If it's 2 weeks, it needs to go through a change review board, it needs to be manually tested and then deployed, you have a problem. Because as soon as a security incident occurs, getting that thing out to production is going to be slow, meaning that the pain is going to continue until you do that. So making sure that your applications can get out into the world quickly and hopefully safely, super important. Next is your breadth of testing. The more things you test, the better. The more tools you're implementing to make sure that you're sort of getting as much coverage as you possibly can, the better. But, of course, there is such a thing as too much, so sort of fine balance there. Then once you've sort of implemented your speed of deployment, making sure you're including security as part of that, usually it's sort of low overhead if you get it early on, and you've got that breadth of testing to sort of test it at the static analysis initial layers of putting code into production or putting code into your repository. Then you've got your breadth of testing for dynamic or fuzzing and on and on. Your mean time to resolution is sort of your next best measurement to say, how well are we actually doing at any of this stuff? And I don't mean the won't fix, accepting risk sort of things, but the how quickly does your team actually recognize that something needs to be fixed, starts working on that fix, and deploys that fix out to production. Most of the time it's really slow. And part of that is because your speed of deployment is slow, but part of that is also because it goes to the backlog, or as I say, dev null, and it never gets seen again. And so now when you eventually have that breach or incident that occurs, well, guess what? It was in the backlog, a la Capital One and others. And so that's sort of a good way to determine how healthy is your application or software security program. And one of the most important things, and this is controversial for most companies, but I'll say it, which is allocate time to technical debt. And security is just another form of technical debt at the end of the day. And your development teams usually know what is most broken and should be fixed inside of your application. You need to sort of lean in on the security a little bit. But I say at a minimum, 10% of their time, 4 hours a week, should be spent on security. Really where you want to be is 20% of their time, or at least 1 day a week. Sometimes it's a 2-week sprint and sort of, 5-sprint cycle or what have you. But again, the time investment upfront made consciously makes a profound difference in the actual implementation of security in your applications. Without it, it's constantly running from one emergency to the next. So free tools to start with. I will say, especially for open source projects, I work at GitHub, full disclosure, but GitHub does have freely available tools as part of the advanced security tool set for open source projects today, so you can use them. There are other great free tools such as SemGrep, really neat tool, and SonarQube. Again, all for sort of static analysis, looking at your code at the very beginning. Dynamic analysis, the Open Web Application Security Project, or OWASP Z-Attack Proxy, or ZAP. Really great sort of starter tool if you're looking to get into some of the web hacking, especially a little bit more manual, but they have some great automated stuff as well. Great tool to get started with. Let's see here, the Web Attack and Audit Framework, W3AF, by Andreas Riancho, that owl-looking symbol. Also really great free open source tool to sort of play around with dynamic analysis, especially good against Java applications. Then looking at your ingredients that you're pulling in, your dependency checking, so Dependabot or dependency check by OWASP. Again, great tools to sort of quickly grab, test them. And then finally, secrets management is one of those sort of banes of most security people's existence, because as soon as you start to find secrets in your code, the next thing you need to do is tell your developers how to solve those problems. Usually they'll just say, well, we'll put it in an operating system environment variable that is still hard-coded somewhere and still gets pulled in. And it's like, no, just use a secrets vault, use HashiCorp vault, use CyberArk Conjur, pull in something and teach them how to sort of create those API calls to pull those keys in dynamically so that you can sort of reset them as you need to. Great tool to make that possible. So if you're looking for further reading, you'll notice none of these are security books, which is actually sort of on purpose. The very first book, and the one that I kind of constantly go back to, is the DevOps Handbook. Read the whole thing, cover to cover, because part 6 is about security, with really great security people implementing and how to sort of put that in your organization. The funny thing is I'm on the record of saying that DevSecOps doesn't exist. It's just DevOps. It was in the DevOps Handbook, but of course DevSecOps sells, and it's sort of the newer mantra. So eventually, because it became my title at Thermo Fisher, I sort of had to embrace it. But great book. If you're sort of more curious about knowing not only if you are interested in getting on the manager's path yourself, or sort of how the managers think about things at different levels of the organization, from sort of a lead engineer all the way up to a CTO, the manager's path does a really good job sort of walking you through that. So you understand the mentality, sort of things that they care about. As was mentioned in the keynote as well, the sort of risks involved in risk-based decision-making that you have to come up with. And then finally, Lean Enterprise. The first half of that book is very much like the DevOps Handbook in a lot of ways. The last half of that book is really where the true gold lies. And it sort of gives you the idea that businesses don't exist to be secure. I know, shocking, right? They don't exist to be secure. They exist to sell you a product, and security is sort of a byproduct of that. And it gives you a lot of insights into sort of the hows and whys behind business decisions, how to sort of rehash or think about how you want to sell security back to the business. And it's a really good way to think about those things. Of course, special thanks. I like to thank just a few people in my life that have really helped me in my career, namely and most importantly, my wife, who couldn't join me on this trip, but she shares my time with the rest of the world. And so I always like to send a nice thank you to her. Hopefully next time I'll be able to bring her and have a glass of champagne or Guinness or some other such thing. Then my sensei and good friend, Jason Haddix, who when I was at BugCrowd taught me a whole lot about bug bounty hunting, and one of the very best human beings that I know. And then my good friend who recruited me to Thermo Fisher and was sort of pushing me to do more, which is Brian Inagaki, who has, again, really pushed me in sort of my career and encouraging me to do sort of new and crazy things. So with that said, it looks like we have just over 5 minutes or so. Happy to have any Q&A now or even after, but would love to get your questions. Happy to provide any sort of perspective that I can offer, with the asterisk that these are my opinions, not the opinions of anyone else or any other organization that I'm affiliated with. So, any questions? Yeah, we got it.
Hi, thank you for the excellent talk. If there's one, you presented a bunch of security tools over there that some of them are familiar with. The others I will definitely be looking into. But what do you feel is really missing from the free security tool landscape right now? If you would get one wish to be completed, what tool would you require someone to build?
I know exactly what I'd ask for. So I'm a very good friends with some of the folks over at Signal Sciences who built just a really wonderful sort of in-application security firewall. And of course, there are free tools out there today, but the implementation that they put together to just sort of catch things at the application layer that I'll tell you, so many network-based firewalls just absolutely missed. And it's sort of hilarious putting it in and bringing it behind those and saying, you still have 2 million attacks you're missing, guys. Like, come on. That's, if I had a free open source tool that I was looking for, that would be it. For sure. Great question. Yeah.
Thank you. Really good presentation. First,
thank you.
You mentioned a little bit about dependencies, right? Like in the case of Node.js.
Yeah.
But what is your opinion about other languages? I think some of them are very overlooked, such as .NET. We don't see too much, vulnerability is happening there, but doesn't really mean like they don't have the same issues. I guess from the Node.js perspective, is because it's pretty widely open, and I don't know if that has to do with the way it's developed. But what is your opinion about other dependencies and the issues that come along with that?
Oh, yeah. I mean, in terms of frameworks and languages, especially like Python, for example, right? Very large sort of dependency landscape there. .NET, Java as well, right? If you think of Apache Struts 2 was made famous by the Experian breach. Super important, right? Especially across the sort of broad ecosystem. That being said, you also sort of have to think about from a business perspective when you're building coverage against that, and from a sort of the way the world is going perspective. PHP is still something like 70% of the internet in terms of all the WordPress sites that are out there. But very few people actually develop PHP on a daily basis anymore, right? So you sort of have to measure that back and forth and say, okay, does it make sense to cover these things in terms of an exposure? I think over time, for better or worse, JavaScript will become sort of the only language that we see on the web. I really hate their sort of laissez-faire use of semicolons, but again, it's sort of, I think that's where a lot of companies are going, is thinking about what's being used by the rest of the world, what's sort of going to be up and coming, what's still sort of around. I mean, even COBOL and Fortran is still used wildly in banks and other places, but nobody thinks about dependency checking for COBOL or Fortran because, well, it's on a mainframe, and it's hard to get those in the first place. So that's sort of a hand-wavy way of saying, yeah, JavaScript, Python, maybe some Java, but after that it sort of becomes niche. .NET especially, it's sort of making a resurgence, but not as much as I say some of the other languages? Great question. Have time for maybe one more? Yeah. One or two more. Depends on how fast I can talk.
I suppose I was interested, you mentioned lots of tools and things you'd like to, you should include in an application security program. And would you say these would be, would these be best done with a dedicated application security team, or are these, do you have kind of a good approach to how you get the development team itself to take on these tasks and build it into the culture?
Yeah, it's an excellent question. That was one of the sort of first challenges I had at Thermo Fisher. So starting with a dedicated team is almost essential, because the sort of idea is what we did is we had members of that team who would hold sort of open forum training classes every Wednesday afternoon at 1 Eastern-ish to get as much coverage of time zones. And we'd invite development teams who we had found vulnerabilities in their code to those. And you'd start to get sort of one or two interested parties that would come in. You'd teach them how to do some really interesting exploitation. You'd sort of give them access to the tools. And then they'd sort of, some of them caught the bug, as we say. Like they'd go back and then they'd start doing all sort of these implementations. And then they became sort of champions within those teams. Honestly, how I expanded my team was then hiring those people, especially the ones that were really good and really knew what they were doing. I'd just bring them in, and then suddenly they became part of the program, and we expanded from there. And now they were sort of a trusted resource, right? Security is sort of still considered the outsider. But if you have someone who was a developer in the team doing those things day to day, knows the applications, and suddenly they're a security person, the developers listen to them. And that's sort of the approach that I had to take with it, is think of yourself as a developer, build the tools for them, show them the tools and train them, and sort of evangelize, for lack of a better term. That's really, but you do need a dedicated team. I mean, for 3,500 or so developers today at Thermo Fisher, there was only maybe a team of 8. So talking about scale, but it was really because we had all those other champions. So anyway, I'm being told that I'm out of time. Thank you, everyone. I'll be around for a little bit, so please feel free to walk up to me and say hello.